Okay, about percentiles, let's check the definition first. If we have a whole data set, we want to divide the whole data set into 100 groups. Then in each group, there are 1% of the values. So for example, we have 300 values in our data set. So if we divided the whole data into 100 groups, then each group will have 3 values. So that's just the basic definition of percentiles. So first, let's check if we are given a value, x, but we want to find what's the corresponding percentile. What should we do? So basic, that's the formula. Okay, we should count how many values smaller than this x. Then divided by the total number we have. So that's the sample size n. Then times 100. That's how we get percentile of a given x value. Let's check the example. We can do the practice together, then we can understand well. So we have the whole data set. Okay, how many values do we have? 50? Yeah, we are given an x value, 11.8. We want to know what's the corresponding percentile for this x. So first of all, when you have a group of numbers, the very first step is try to sort the data from the least to the greatest. First step, we need to sort the data. But this example, the data has already been sorted, right? It's already from the least to the greatest. And we can circle where is 11.8. It's right here. It's right here, 11.8. Then from the definition, how can we get the percentile? We only need to count how many values are even smaller than this x value, 11.8. So from this table, we can easily find the first 2 rows are smaller than 11.8. So we have 20 values, even smaller than 11.8. And we should divide it by how many values do we have in all. Of course, here, the sample size is 50. We totally have 50 numbers in our data set. So by the formula, x value is just 20 values smaller than 11.8 divided by 50 value we have in all times 100, we will have 40. Then we know 11.8 is just P40. Or we can say it's just the 4 days percentile. Or we use this notation, P40. So the meaning is the whole data set. If this is the whole data set, we use this P40 to separate the data set. So here is 40%, and here is 60%. And this is our P40 equals 11.8. Which means we can use this percentile to separate the data into 2 groups, the lower 40% and the higher 60%. Let's check some notation. Okay, n is still the sample size, or how many numbers in our data set, how many values. Sample size, that's K is a new definition. So for example, we will say if it's 25th percentile, then K is equal to 25, which means P25. Then this one is our K. For, of course, P35, then K is equal to 35. Okay? And L means the location or the position. If L equals 12, which means in our sorted list, L is the 12th value. L is the 12th value. Of course, PK, because we already know K. So PK is the kth percentile. If K is 25, P25 means the 25th percentile. After we learn the notations, we will learn how can we convert a percentile to an x value. So first step, we have an x value. We want to find the corresponding percentile. This time, we know the percentile. We want to convert the percentile to the corresponding x value. So what should we do? Let's just check this one. Don't forget, no matter we do the x value to percentile or percentile to x value, we always need to sort our data first. Put them in order, okay? From lowest to highest. After that, we need to compute this one. So this is the formula. Remember what's the L? L tells you the location of the x value. So K is about the percentile. K divided by 100 and then times n. But we will have different way here. Depends on if L we get is a whole number. Yes or no? If yes, it's a whole number. After we get to the value of L. If it's a whole number, then the value, the x value we were interested is the midway between L's value and the next value. So if it's a whole number, we need to check two numbers, then try to get the mean of these two numbers. But if it's not a whole number, it's a decimal, we only need to check the next larger whole number. Okay, then that value is just the value we need. You can check it carefully. We have different situations. I will show you the example to help you understand. Okay. So this time, we want to find what's the x value corresponding to 40th percentile. So we already know P40. We want to convert to x. Okay. First, we need to sort our data. So this table already been sorted. Next step, we use the formula. Remember, we use the formula. This is the formula to get the location of our x value. So in this case, we are interested to find the P40. So 40 is our K. 40 divided by 100 times n. N is the sample size. We have 50. So it will be like this. Right? 40th percentile. So K is equal to 40 divided by 100. times n. N is how many numbers in our data set. So we will get 20. Now we should check the answer of our L and ask ourselves a question. Is this a whole number? Of course, it is a whole number. So if it is a whole number, we need to check. This is a little complicated. The middle way between L's value and the next value. So let's check what does that mean. We need to check 20th value and the next value. So if it's a whole number, we need to check 20th. So 10, 20. So this 11.6 is just 20th value, right? And we also need to check another value, the next value. So that's the 21st value will be 11.8. So if L is a whole number, we need to check two values, then try to get to the mean value. So how can we get to the mean of these two values? We add them up. We add them up. 11.6 plus 11.8. Then divide the sum by 2. We will get 11.7. Okay? So that's the meaning why when the L is a whole number, we need to check this value and the value right behind it. So in this case, L equals 20. We need to check 20th, and the one behind it is 21st. Then try to get the mean value of these two numbers. Okay? But for example, if sometimes we get L is not a whole number, let's say if we have 20.1. This time it's not a whole number, so according to the procedure, we only need to check one value and always round up to next whole number. So it will be 21. So we will only need to check which value is 21st. Okay, if it's not a whole number, we only need to check next whole number. If it's 20.1, then we only need to check which value is just the 21st value. But if it's whole number, we need to check two values, then try to get the mean. This is the rule how we get the corresponding x value for a percentile. But if you check this one with the previous example, maybe you will find the first time we have this conclusion. 11.8 is equal to 40th percentile. So it's kind of interesting when we go this way. 11.8, we know 11.8 is corresponding P40. But when we already know P40, we will find 11.7 is the corresponding x value. It's totally possible. Okay, so don't think you made a mistake. It's possible. Maybe it's a slightly difference between because you go this way, you will get this. You go that way, you get another. So it's possible. Next definition is quartiles. In the quartiles, we only have 3 quartiles, and this is the notation Q1, Q2, and Q3. So quartiles only separate the data into 4 groups, and each group has 25%. So Q1, Q2, Q3. Each group is just 25. A quarter is just a quarter, right? Percentile separate them into 100 groups, and the quartile divided the data set into 4 equal groups. Each group has 25% of the value. And how can we get the value of quartile? We just use percentile to get the quartile. And we should know Q1 is just the same value as P25. So it just means we can use P25. And we know P25 is just separate the whole data set into the lower 25% and the upper 75%. Right? The lower 25%, another part will be upper 75%. So that's the same meaning as Q1. So similarly, Q2 is P50. We can also say it's just the median. It's just the same as the median. So it separates the data into 2 parts. The top 50% and the bottom 50%. Q3 is just P75. It separates the data into the top 25% and the bottom 75%. Okay. We have another measure called interquartile range. So it's just Q3 minus Q1. It's just third quartile minus first quartile. How can we get it? We use P75 minus P25. Of course, another called semi-interquartile range. These two are not so important. We only need to know the name. All of the things are not very important. It's just some names. And these will not be in our test or exam. But this one is important. This is called 5-number summary. So for a data set, we can list the most important 5 values. Then we call it 5-number summary. Which is minimum value, Q1, Q2, Q3, and the maximum value. These are the 5-number summary. So we can work the example together. So for the same data set, if we want to find the 5-number summary, first we need to sort our data. Okay? We need to sort the data. After we sort the data, it's easy to get the minimum data and the maximum data, right? So the minimum is the first one, the maximum is the last one in a sorted data. After that, we only need to get the percentile. So Q1 is P25. So Q1 is P25. For example, how can we get this one? 25. If it's 25, P25, which means K is 25. So 25 divided by 100 times 50. We will get 12.5. 12.5 is not a whole number. So we only need to check the next one. Only need to check the next whole number. So it's 13th. So 10, 11, 12, 13th. So Q1 is 70.9. And if we talk about the Q2, that's P50. Okay, then we use the same formula. This time K is equal to 50. 50 divided by 100 times 50. We will get 25. Now we realize 25 is a whole number, which means we need to check 25th and the next one, 26th. So we check this two and try to get the mean of these two values. That will be our median, P50 or Q2. Similarly, we can use the formula 75 divided by 100 times 50 to get the P75. We will get, so it's the 35. So which means we only need to check the 38th. So this is how we get Q1, Q2, Q3. We just find P25th, P50th, P75th. After that, we can list them. We can list the answer here. It's from minimum, Q1, Q2, Q3, and the maximum. Okay. Then we can use this 5-number summary to draw another graph called Boxplot. So before we draw a box plot, we need to list the 5-number summary first. Then this is show you how can we get the box plot. So this is an example of box plot. First, we should know the 5-number summary, right? If we want to draw a box plot, we first step draw a line segment from minimum to maximum. Then we find the approximate position to draw 2 bars. This will be our Q1 and Q3. Okay, then we draw this box. So the last step, we set the Q2. So for the approximate position, it's about here. So it's Q2. Then we label it minimum. We know it's from minimum to maximum. And this Q1, Q2, Q3, we can label it. So the position of the bar is not necessary to be accurate. It's just a sketch, okay? So you only need to know it should be from minimum to maximum. And this is the box from Q1 to Q3. And we have a Q2 inside the box. But the most important part is we need to list the 5-number summary first. So we can also use the box plot to help us check the skewness. Okay. And I think the remaining part is not important. We can just stop here. Okay. We can also use the box plot to check the skewness. If the box is not symmetric, it's more to one side, we will say. If the box is, for example, the box is on the left,